Assalamualaikum, my name is Mohammad Farzam Siddiqui and I welcome you to this video. Today we'll be solving the AS level physics paper for February March, and this is the theory paper that we'll be solving. So let's get started with it. So the first question that we have is starts with the definition of force. So the definition of force is a bit changed when you come into A levels. So it is the definition of forces, it is the rate of change of momentum. Right. Then it says that use the definition in part A1 to show that the SI base units of force are kilogram, meter, second, square inverse. Right. So there are many ways to show that the units of force are kilogram, meter, and second square inverse, but we need to use the definition. So we know that force is equals to delta P, that is the change in momentum over time. Right. So now if you apply the units, so units of force would be now momentum can be written as kilograms per meter per second, that is mass into velocity divided by the time, that is second. Right, so now if you just solve this, bring s up in the numerator, your units of force would be kilogram meter s minus 2. So yeah, we have proved it using the definition, right, as stated in the question. Then in part C, it says that we have a student who is investigating the relationship between the force applied to the piston of a syringe and the velocity of the fluid exiting the syringe. So we have an equation which relates the velocity with the force with the spring constant of that syringe, right, with the mass of the fluid and the cross sectional area of the piston, right? So these are the five, I think we have five variables which are related here. So by considering SI base units on both sides of the equation, we need to state and explain whether this equation is homogeneous or not. So what is homogeneity? Homogeneity means that for any equation, the terms right on the right hand side of the equation, they should have the same units on the left hand side. All the terms on the right hand side should have the same units on the left hand side terms, right? So we only have one term here, right? We have single terms on each side. We have one term that is speed over here, or the velocity, and we have the second term which is the complete expression. So if these terms have same units, then this equation would be homogeneous, right? So let's work out the units of velocity. So units of velocity are, that is meter per second, right? Just like that. And then we need to determine the units of this whole expression. So let's find out the units. So the units of this would be FKM over A. So units of force is kilogram meter square second square inverse multiplied by the spring constant, which is F is equals to Kx. So this is kilogram per meter, right? And then we have the m, which is the mass, so this would be kilograms again, and area is meters square. So if you work this out, so this would be, this kilogram would be cancelled with this kilogram, right? This would be meter and meter minus 1, so your resulting units would be kilogram, uh, meter minus 2, right? And then second minus 2. So we can clearly see that the units on the right hand side of the equation of the left hand side of the equation, they are not same. So we would state that the equation is not homogeneous. The equation is not homogeneous because the units at either side of the equation are not same. Equation are not same, right? So this would be the answer to this part. Right, so this ends our question one. Let's move on to question number two. Now, in question number two, it says state the principle of conservation of momentum. Right, so the principle of conservation of momentum. So you need to identify the keywords for this statement. The first keyword is that for a closed system. Remember that this should be a closed system. Right, what we understand by closed system, that no mass can go outside and no other mass can inside, which means there would not be any external force. So for a closed system, this momentum, the total momentum before collision, the total momentum before collision will be equal to total momentum after collision, to the total momentum after collision, right? Then in the next part, part B, it says that a stationary boat of mass 160 kg floats on water. The mast, now we have a mast here of the boat, which is vertical, and a sack which has a mass of 23 kgs. It is thrown at the boat with a speed of 3.4 meter per second, or you can say with a velocity that is directed towards right with a magnitude of 3.4 meter per second. So the stack collides with the mast and remains in contact with it without rebounding. So assume there are no resistive forces. Calculate the horizontal speed v of the sack and boat immediately after the collision. Right. So first, if we talk about the boat along with the mast, so it doesn't have any velocity. Initially, it is stationary, right? And the mass of this stationary boat is of 160 kg, right? And the mass of the sack is 23 kg. So we can apply the conservation of momentum. The total momentum before would be, the boat doesn't have any velocity, so it would be just 130 times 0. It wouldn't have any momentum, right? And then the sack has a has a speed of 3.4. Okay, that's 160. The mass of the boat, that is 160. And then we have the sack, which has a mass of 23 kgs, right? And it has a velocity of 3.4. So this is the total momentum which we have before collision. And after collision, they both stick together. So now they act as one body. So their combined mass would be 160 plus 23. And we need to find their velocity. Right? So if we work this out, so we can easily find their velocity. Right? So this their velocity would be 160 plus 23. And 23 into 3.4, that is 23 into 3.4 divided by 183. So I'll just calculate this. So if I can calculate this using my calculator, I'll get it around, that is 23 into 3.4 divided by 183. So this is 0.43. Right, so this is 0.43 meter per second. Okay, so this would be the velocity of the combined mast and of the boat and the sack, right? Then it says the total kinetic energy of the sack and boat immediately before the collision is E1. The total kinetic energy of the sack and boat immediately after the collision is E2, right? So determine the ratio E2 over E1. So of the sack and boat. So initially, when we are talking before the collision, the boat won't have any kinetic energy because it doesn't have any speed. It is stationary. Only the sack will have the speed, right? So the kinetic energy before, that is E1 would be equals to half m, that is your half m. The mass is 23 multiplied by 3.4 square. This will be your E1, because initially you will, before collision there would only be movement, or the kinetic energy would only be due to the sack. And in E2, they both are now the same. They are now attached. So the total mass is 183. And that speed that we have is 0.43, I guess. Yeah, 0.43. 0.43 square. So you just need to divide it to get the ratio. So if I divide E2 by E1, so the answer that I would get would be 0.13. So my answer is 0.13. The ratio is 0.13. Now I would say the state and explain whether the collision between the sack and boat is elastic or inelastic. Now for in inelastic collision, your total kinetic energy before a collision and after collision, it is conserved. But in inelastic it is not. So if your energy would have been conserved, your ratio would have been, these values would have been same. So your ratio would end up being 1, but it is not. This means that because the ratio is not 1, this is an inelastic collision. So first we will state that it is an inelastic collision. It is an inelastic collision because E1 and E2 are not same or not equal, you can also state that the ratio E2 over E1 is not equals to 1. This means the same thing. Right, then it says after a short time, the boat in 2B is at rest again. Show that the upthrust acting on the boat with the sack is 1800. So, when this boat is stationary, let's say this is the water body, and we have the boat right here, right, with the mast and the sack, right. So if I made it like this, the mass of the boat, which is the weight, sorry, the weight of the boat will be equals to the upthrust when it is stationary, right at this point, because it is not floating, it is not sink, it is just floating, it is not sinking. So the weight is being balanced by the upthrust force. So in this case, your upthrust would be equals to mg, right? So m is 183 multiplied by 9.81. That is the acceleration due to gravity. So if I work this out, I would get something closer to 1800. Not completely 1800, yeah, but yeah, I'll get something that is 1800. So I'll just write 1800 here. So this is my force, upthrust force. Then it says the boat displaces water with a volume of 1.8 times 10 to the power 5 centimeter cube. Calculate the density of the water. Give your answer to three significant figures. Now the formula for upthrust is basically the mass of the water that is being displaced, the weight of the water. Right? So the formula is rho g v, where rho is the density of the liquid, g is the acceleration due to gravity, and V is the volume that you have displaced, right? So we know the upthrust is 1800. We need to find the density. We know the acceleration due to gravity, that is 9.81, and we know the volume, that is 1.8 times 10 to the power 5 centimeter cube. So this need to be has to be a conversion for it now. So we know that 1 meter is equals to 100 centimeters. So if I do cube on both sides, right? So this will be 1 meter cube is equals to 10 to the power 6 centimeter cube, right? So we will just multiply it by 10 to the power minus 6 to do the conversion. Now density would be equals to 1800 divided by 9.81 multiplied by 1.8 times 10 to the power minus 1. So if you just work this out, your density would be equals to 1.02 times 10 to the power 3 kilograms per meter cube. 1.02 times 10 to the power 3 kilograms per meter cube. Okay, and now let's move ahead. So this was the end of question 2. Now let's moving on to question 3. So in question 3 we have a roller coaster, right, which has a mass of 280 kgs. It travels over a raised section of track, right, and at x position, the position x, the carriage has kinetic energy 16.1 kilojoules. At position y, the carriage has kinetic energy 1.3 kilojoules, right? The length of track between x and y is 23. So we have the length, right, between x and y, which is this part right here. This here, this length, right? And then it says in moving from x to y, the carriage does 5.1 kilojoules of work against resistive force. Calculate the resistive force. So that is very easy. We know that the work done is basically equals to force multiplied by distance traveled in the direction of force. Now, because this is a curved path, so the direction of force would be different at each point, right? Some place it would be this. That's why it has said that the average resistive force, right? So the work done that we have is 5.1 kilojoules. This will be 5100. The distance that we are moving is of 23 meters, and from here you will get your force. So force will be coming equals to 5100 divided by 23, that is 220 newtons. Then in the second part it says calculate the change in height delta h between x and y. So now we will apply the energy conservation over here when we are moving from x to y, right? So it gains potential energy, and it will be at a cost of kinetic energy. Kinetic energy would be decreasing. There would be a loss in kinetic energy, and your potential energy would be increasing. But because we have a resistive force, there will be work done against the resistive force. So we can say that loss in Ke is basically equals to work done against friction or work done against resistive force, right? Plus your gain in GPE, right? So the initial kinetic energy that we have is at position X, the carriage has kinetic energy 16.1 kilojoules, and at position Y, the carriage has kinetic energy 1.3. So let's find the loss, that is 16.1 minus 1.3. 16.1 minus 1.3. This would be the loss, kilojoules, 10 to the power 3. Work done is how much? Work done is 5.1, that is 5100 plus mgh, right? So if you just work this out, this will be equals to 16.1 minus 1.3 times 10 to the power 3. So this gives us, yeah. So your change would be 9.7. This whole, your mgh will be equals to 9.7 times 10 to the power 3. That is 9.7 kilojoules. Right, now we need to find h. So we need to know the mass of the carriage. So that is 280 kgs. Right, so this will be, your h would be equals to 9.7 times 10 to the power 3 divided by 280 times 9.81. So this gives us the height. The height is around 3.5 meters, right? Okay. Then in part B, it says the carriage travels further along the track to point Z. Instead, and explain whether the speed of the carriage at Z is greater than, less than, or the same. So now if we look at point Z is at the same height at X, right? They have the same altitude. So if we talk about an ideal case, because in an ideal case, there is no loss, no work done against friction. So from here to here, the change in kinetic to potential would be the same because the height difference is same. But because there is some work done against friction, so that work done is lost. This 5100 joules is as lost. This energy has been lost as in other forms. It could be due to heat losses, right? It could be due to sound or any other energy. So it means the energy would be less, right? So it's determine whether the speed of the carriage. So if your kinetic energy is less, your speed will also be less. So speed will be less. Speed will be speed at z will be less than the speed at x, because some energy is lost, is lost as work done against resistive force. So this was the last part of question 3. Let's move forward to question number 4. So in question number 4, we have a uniform square picture which is attached to a wire and hangs in equilibrium from a pin at point P as shown in figure 4.1. So we have figure 4.1, like here we have a point P here, and we have a square uniformly distributed load, a uniform square picture which is attached to a wire. We have the same tension in both the wires, right? And they are both at the same angle, that is theta. The center of gravity, this means we have a weight of 19 Newton for this square picture, right? The picture has weight 19 newtons. That is already stated in the picture also. And it says the wire forms an angle theta with the horizon. The tension T in the wire is 13 newtons. Define the moment of a force about a point. So what is moment? Moment is the force multiplied by force into the distance. Perpendicular distance. Force times the perpendicular distance from the pivot or from the point, right? From, from the point. And then it says explain why the moment of the weight about P is 0. So why the moment of the weight about P is 0? So if you see, if we take P as the pivot, or P is the moment, the point about which we are taking moment, so the force, the force, the weight is in the line of action of force. So it won't have any perpendicular distance, because this is the direction of force. The only perpendicular distance would be this horizontally, right? But it is alongside, it is parallel to the line of action. So the weight is along the line of action of point P, right? So there will not be any, what we call, there would not be any perpendicular distance, hence there wouldn't be any moment. Then it says calculate theta. So now we would need to apply something here, some equations of equilibrium. It says that it is an equilibrium, right? So we can resolve these tension forces into its x and y component. So we will have the x component, right? And we will have the y horizontal component. Also, we will also have the same for here. This is same, right? And this would also be the same. So this would be equals to t sine theta, right? This would also be t sine theta, and these two would be t cos theta. So now we have two conditions for equilibrium, that your resultant force should be zero, and the first one is resultant force should be zero, and the second one is resultant moment. So we already know that there is no resultant moment, because the only force which would be making resultant moment would be this. If you talk about tension also, so they would have the same perpendicular distance, right? And they are the same forces, and they are on two opposite sides on the pivot. So they will have the same moment but opposite in direction. So that moment will also be cancelled out. Now coming back to the forces. So the weight is being balanced by the two components of the tension here. So we can say that t sine theta is basically 2t sine theta. 2t sine theta is equal to the weight, that is 19 newtons. 19 newtons. Now you can easily find theta. We already know the tension is, I think, 13 Newton. Is this provided in the question right here? T is 13 Newtons, right? So we can use this. So T in the wire is 13. So this means your sine theta would be equals to 19 upon 26. That is 2 times 30, right? So your angle would be something sine inverse of 19 upon 26. That is around 47 degrees, right? Okay. Then it says that the wire has a diameter of 0.8 millimeters and is made up of metal with Young modulus 9.3 times 10 to the power 12, 10 to the power 10 pascals. The wire obeys Hooke's law. Calculate the strain in the wire. So first, we already know the tension in the wire, that is 13 newtons. So by using the tension and the area, we can find the stress, right? So stress is equals to force over area, and force is 13 here. Area is basically, we take wire as cylindrical. So this will be pi d square over 4. Now the diameter is 0.8 times 10 to the power minus 3 square over 4. So this 4 will go up, right? It will come into the numerator. So I'll just remove it from here and adds it to the numerator, right? So this is the complete expression for the stress. So first you will find out this is stress, right? So this stress would be, this would be your stress. Once you have found your stress, so your Young modulus is stress over strain. So strain would just be equals to stress divided by the Young modulus, which is 9.3 times 10 to the power 10. Right. So if I write the complete, uh, what we call the complete expression for strain, it would be strain equals to stress, which is 13 times 4 divided by pi times 0.8 times 10 to the power minus 3 square into 9.3 times 10 to the power 10. So this would be giving you strain. So strain is 2.8 times 10 to the power minus 4. 2.8 times 10 to the power minus 4, and strain does not have any units, because it is a unitless quantity, it is a ratio. Then the bottom side of the picture shown in figure 4.1 is 1.6 meter above the ground. The pin at P breaks and the picture falls vertically downwards. Resistive forces acting on the picture are negligible. Calculate the time taken for the bottom side of the picture to hit the ground. So it says that it is above 1.6 meter above the ground, right? So because there are no resistive forces, so we can just say that it is falling with the acceleration due to gravity. There is no air resistance. So we can apply the equation of motion. So it will be falling from what we call rest. So we can apply this equation of motion. S is equals to ut plus half at square. And because it falls from rest, because initially it was at equilibrium, so this expression is 0 right here. So the distance is it drops is 1.6 meters, right? The acceleration would be 9.81, and we need to find time square. So time would be equals to 1.6 times 2 divided by 9.81 square root, right? So your time would be 0.57 seconds, right? 0.57 seconds. Then it says on figure 4.2, sketch the variation of the speed of the picture with the distance fallen from its initial position. Now, this is something new. We have drawn graphs for speed and time, distance and time, right? But we have not drawn graph for speed and distance, right? So how would you draw it? So we can use any equation. So we can use the acceleration due to, let's say, we can use any one of the equation. So let's use this equation: 2s is equals to v square minus u square. Let's change this a bit, right? So initially it is 0. There is no speed, there is no what we call it, no initial velocity, so it would be 0, right? So if I now find an equation connecting displacement and this, so it would be this, right? So because acceleration is constant, we can say that displacement or your speed is directly proportional to the v square, right? So this means your v increases more than the distance, so your graph would be more bent towards your speed, right? Because distance increases less, but it is velocity square, right? So it would be like this. So it would be, and because it is coming to 0 point, so it would be something like this, right? It would, or something like this. It would be a curved line with an decreasing gradient, right? Your gradient would be decreasing. So this would be it. Yeah. Now, let's move on to question 5. So, in question number 5, it says for a progressive wave, state what is meant by period. So, it is the time taken to complete one wave, time taken to complete one wave, one wave or one cycle, right? Or one rotation, anything that is suitable here. So, then it says the amplitude. So, it is the maximum displacement of a particle, displacement of a particle from its mean position, particle from its mean position, right? From its mean position. All right. Then in part B, it says we have a stretched spring which is fixed at both ends and made to vibrate with the frequency of 25 hertz. A stationary wave is formed on the string. The distance between the fixed ends of the string is 0.96 meter. We have a figure for that. Now, on figure 5.1, we need to draw a cross to show the position of an antinode. Right, so if I draw the stationary wave, so the stationary wave would somewhat look like this, right? We will have loops. Now, this is not a very good depiction, but yeah, this is just to give you an idea how the stationary wave looks like, right? These are loops here. So the antinode is the point with the highest displacement. So these would be the point. This would be an antinode, or you can say this would be an antinode, any one, right? Draw cross at the position. So you need any one. So I'll just mark one antinode here. Then it says show that the speed of a progressive wave on the string is 16 meter per second. We already know the frequency. If we can find the lambda, the wavelength somehow, we can find the speed. Now, how you can find the lambda? Because we know that length of one loop, right? Length of one loop is basically equals to lambda by 2. Now, how many loops we have? We have one loop, two loops, and three loops. So this means this is the length of three loops. Then this 0.96, this total length is of three loops. So this means that the length of three loops, that is 3 lambda by 2, is equals to 0.96. So you can find your lambda from here. It would be 0.96 times 2 divided by 3. So this would be your lambda. So your lambda would be coming something around 0.64, right? And then using your lambda and the general wave equation, which is v is equals to f lambda, you can find your frequency. V is equals to f lambda. Your v is frequency is 25 multiplied by 0.64. So this would be coming equals to 16 meter per second. All right. And then it says the frequency of the vibrations is increased to 30 hertz. The speed of the wave on the string does not change. State and explain whether a stationary wave is formed. Now remember, a stationary wave is always formed at particular frequencies, which are called harmonics, right? We have the rules for harmonics that either the smallest frequency at which your stationary wave is called formed is called the first harmonic. And then after that we have the second harmonic, and then the third harmonic and fourth harmonic, just like that. So your frequency, this 30 hertz, should be one of the harmonics. If it is an harmonic, this means that there would be a stationary wave. If it is not a harmonic, this means there won't be a stationary wave, right? So let's check for that. So we have one of the waves at one of the wavelength. We have at a wavelength of 0.64, right? Or the frequency of 25 hertz. These are one of the harmonics. Now, what if I increased my loops, right? First, there were three loops, right? Now, how many loops could there be if I talk about, right? If there are both antinodes here, so there could be multiple loops. Your loops could increase from three to, I could have how many loops? Let's say if I make a wave like this, if I have a wave like this, right? Something like this. So, how many loops would I have? One, two, three, four, right? So I would have one, two, three, four loops, right? I would have four loops here. So my loops could be three, four, one, or two, right? Depending on my wavelength. So what would be the frequency at the four loops? So your wavelength for this four loops would be, let's see, your wavelength for this four loops would be 2 lambda is equals to 0.96. So your lambda would be somewhat 0.96 divided by 4 would be 0.48. And we have the speed of 16. So V is equals to F lambda. So 16 divided by 0.48 will be your frequency, right? So you will have 1600 here. So this will be 1600 divided by 48. And this would be 1600s are 16 threes are. So your frequency should be something around 33.33 something, right? It's going to be 33.33 something, right? So this means 30 is not a frequency, 30 is not an harmonic. So we won't have any frequency, right? We won't have a stationary wave formed at it. All right. So student explains whether a stationary wave is formed. So no, because stationary waves are formed at harmonics, and the next is stationary wave, and the next is stationary wave would be at a frequency of 33.33, frequency of 33.33 hertz, right? Okay, then it says in C, we have a beam of light which has a wavelength of 4.5 times 10 to the power minus 7. It is incident normally on a diffraction grating, right, which has 6.7 times 10 to the power 5 lines per meter. So these are the number of lines that we have, right? It passes through the diffraction grating, and then we have bright spots. The angle formed at the diffraction grating between the central bright fringe and the bright spot at position x is 37. So we need to find the order. Now we know everything, right? We know the formula that n lambda equals d sine theta, right? But d is the spacing, right? Over here we are provided with the number of lines per meter. So your d would be equals to 1 divided by 6.7 times 10 to the power 5. So this is your d. D is basically, this means that in 1 meter, in a span of 1 meter, we have these many lines, right? D means what is the spacing between the two lines in the diffraction rating, right? That's why we call it the diffraction spacing, the D. Okay. So we need to find the order, that is n. We already know the lambda. The lambda here is 4.5 times 10 to the power minus 7, right? We know the D is 1 upon, I think it was 1.5 times 10 to the power 7. 6.7 times 10 to the power 5. Alright, this is your D, and then sine is sine of 37. So if you make everything the subject, this would be n would be equals to sine 37 divided by 4.5 times 10 to the power minus 7 into 6.7 times 10 to the power 5. So this should be coming equal to 2. Right? And then it says the diffraction grating is replaced by grating with fewer lines per meter, right? State whether the distance between adjacent bright spots on the screen increases, decreases, or remains same. So by distance, it means this distance. So if your distance is increasing, your angle is also increasing. So we are talking about the sine theta here, right? So because this is sine theta, we know that at theta is equals to 0, sine is also 0. Sine theta is also 0. And at theta is equals to 90, sine theta is 1. So the value of sine increases from 0 to 90, right? So if this distance increases, your angle also increases. And if your angle increases, your sine theta value also increases. So we need to relate it with the diffraction grating, right? So I'll just use this formula. We know that n lambda is equals to d sine theta, right? Now I can write d in this way. N lambda is equals to d would be 1 upon the number of lines. I'm writing it NOL, right? Sine theta. So now we need to relate NOL with sine theta, right? So NOL is equals to sine theta upon n lambda. Now keeping everything constant, right? Your order is the same for the same order, that is for the second order, right? So and your wavelength is also the same. So the number of lines is directly related to sine theta, which means if your number of line is increases, right, your sine theta also increases, which means your distance also increases. So it says the diffraction grating is replaced with a grating with fewer lines. Fewer lines means your number of lines decreases, so your sine theta also decreases, right? So state whether the distance between adjacent bright spot on the screen increases or decreases. So it decreases, right? This is just a one max answer for the statement. There is no explanation for it, right? So it decreases. So this was the end of the wave question. Now let's get ahead of it to question number 6, which is electricity. So state what is meant by electric current. So it is the rate of flow of charge. All right. Okay, then it says we have a cell which has an electromotive force of 1.5 volts and an internal resistance of 0.75 ohms. On figure 6.1, we need to draw the variation of the terminal PD with current. Now, this is a very easy thing, right? So we know that if we apply the Kirchhoff's second law, right, on a circuit which is having any internal resistance, so the equation would be we will have the EMF. Your EMF would be equals to the potential difference, right? The terminal potential difference. Let's call it V terminal Vt plus IR, right? So this is your waste energy inside the cell and this is your terminal potential difference. Now I want to plot a graph against Vt and current. So this will be Vt will be equals to minus IR plus E. So now if you compare it with the equation of a straight line, which is y is equals to mx plus c. So y is your terminal potential difference, I is your current, right? I is your x-axis, I is your current, and minus R is your gradient, and E is your y-intercept. So we have an EMF of 1.5 volts. All right. Yeah. So at 1.5, this would be my EMF, right? This is my y-intercept. Now I need another point, right? So I have an internal resistance of 0.75. That is my gradient. So your equation would be y is equals to minus 0.75 x, or we call it terminal potential difference. Vt is equals to minus zero point 0.7 x, that is my current value, 0.7 I plus 1.5. So this is my equation of the straight line according to my given values. Now I need one other point to plot the graph. So you can take any value for the current, right? Let's say I take the value of 1.6 for the current. So Vt is equals to minus zero point 0.7 into 1.6 plus 1.5. So this will be equals to minus zero point 0.7 into 1.6. So this is negative 1.12 and then negative 1.12 plus 1.5. So negative 1.12 plus 1.5. So this gives us 0.38. So we would have a voltage of 0.38, right? So this is 0.25, right? So this is 0.25, yeah, 0.25, 0.3, 0.35. So it would be something around here, right? Something around here. So this would be your second point. Just draw these two lines and you will have your graph. So this is your graph for the potential difference, terminal potential difference, and the current. Then it says we have a metal wire X which has length 6.8 meters right? We have a cross-sectional area of this wire and we have the resistance of this wire also, right? So now we have the same battery, same cell which was discussed in the previous part. We have the same cell which is now attached into the circuit, right? It is providing us with a current of 1.8 amperes, right? So what we need to find first, we need to find the resistivity. So for resistivity, everything is provided. We know the cross-sectional area, we know the length, we know the resistance. So just we will apply the formula that R is equals to rho L over A. So we need to find rho. So rho would be resistance, which is 0.82 multiply the area. Area of this cross-sectional area is something 2 times 10 to the power minus 7, and then we have the length, which is 6.8. 2 times 10 to the power minus 7. This would be in the numerator because it is Ra over L. So 2 times 10 to the power minus 7 and then 6.8. So this would be the formula for your resistivity. 0.82 into 2 times 10 to the power minus 7 into 6.8. Yeah. So if you find the resistivity from here, your resistivity would be somewhat 2.4 times 10 to the power minus 8. 2.4 times 10 to the power minus 8. Okay, then you need to find R. Now, what is R here? R is the resistance of the terminal resistance, right? So for this, we already know this is 1.8 amperes. So now we will use our graph that what would be the terminal potential difference at a current of 1.8. So we look at the value for 1.8. So this is 1.5. This is 1.55, right? Okay, the current is here. So the thing is, this I don't have any values here for the current is 1.8 amperes, right? Okay, now this 1.8 amperes is divided, right? It would divide, some would go here, right? And some would go here. So it says here that, wait, what would be the terminal potential difference at the current of 1.8? The resistance of the wire is 0.82. We know the resistance is 0.82. All right. Okay. So calculate R. The current in the cell is 1.8 amperes. Right. The current will have terminal potential difference as 1.5, and the EMF is 1.5, and we have IR is equals to 0.75. So let's just apply the Kirchhoff's law on this loop, right? So if you apply the Kirchhoff's law on this loop, so we will have the EMF, right, which is 1.5 is equals to current. Now we again don't know the current here, right? This would be I into capital R plus 0.75 into I, right? So this is what we have the equation for. And if you look at the second, if we apply this here, right? No, this would be I into, this would be 0.75 into 1.8, right? And if you apply the second loop, this which was this loop, so this would be, I'm calling it I1. This one is I1 and this one is I2, right? So this would be 1.5 is equals to I2 into 0.82 plus 0.75 into 1.8. So I can find I2 from here. I2 will be equals to 1.5 minus 0.75 into 1.8 divided by 0.82, right? So this would be equals to 1. This is coming to be 1.8. So this I2 here is 0.18, right? So we can easily find I1. So 1.8 minus 1.8 minus 0.18. So this is coming to be 1.62. This is 1.62. Now we know the current here. This is 1.62, right? So now we can apply, we will use this equation to find R. We will apply this equation to find R. So this will be 1.5 minus, again, we will use it. 1.5 minus 0.75 into 1.8, right? Over here, your resistance, your current would now be 1.62. So 0.09. 0.09 ohms, right? Okay. Then it says calculate the power dissipated in the internal resistance of the cell. So power is equals to I square R. We know the current is 1.8 square. The resistance is the internal resistance is how much? Internal resistance is I think 0.75. Yeah, 0.75. So it is 0.75. So you can easily find the power dissipated from here. Right. So after this would be 2.4 watts. 2.4 watts. Right. Okay then. So now let's come to the last part. Describe the structure of a nuclear atom. So this the question is relevant to the goal foil experiment. You need to explain your conclusions. So what was the structure? The atom is mostly free space, right? Mostly free space with a positively charged, positively charged nucleus at the center, at the center, right? Then in part B, it says that P and Q are radioactive nuclei. P has 94 protons, Q has 91 protons. Each nucleus decays to form a nucleus with 92 protons. State the type of decay experienced by P. So it is 94 protons to and it has to decrease to 92 just by one radioactive decay. Right? So this would be alpha because in alpha decay your proton number decreases by 2 and your nucleon, that is proton plus neutron, that decreases by 4, right? That says it is the type of radioactive decay experienced by Q. So it has 91 protons, it has to become 92 protons. That means your proton has to increase. So this would be beta negative decay because in beta negative decay one neutron changes to proton, right? Then it says we have a particle X which has a ratio of charge of mass equal to 1.76 times 10 to the power 11 coulombs per kg. So identify particle X, show your working, right? So I think the defining the what we call it, the unique feature would be here, over here would be the mass, because your alpha particle would also have the same charge. We cannot either you can find the charge, right, or the mass using it. So because it has a charge to mass ratio of plus 1.76, this means this is a positively charged particle, right? So let's work this out. This would be more like an hit and trial method. You need to think of it. So assuming this is an alpha particle, right? This is an alpha particle. So let's find out the charge for an alpha particle. So the alpha particle has 4 protons. So you charge for it 2 protons. Sorry. So the charge would be 2 into 1.6 times 10 to the power minus 19. That is 3.2 coulombs, right? So it should comes equals to this. An alpha particle has 4 uh, nucleons. That is 2 protons and 2 neutrons. So the mass would be 4 times 1.66 times 10 to the power minus 27. So let's find the charge here. Charge over mass. 1.66 times 10 to the power minus 27 into 4 is equals to 1.76 times 10 to the power 11. Let's see what charge do we get. Right, so if I work this out, so this is 1.76 times 10 to the power 11 and then 1.66 times 10 to the power minus 7, right? So this is what we have. So the charge here is now the charge value is not equals to what we should be getting. It is 116864. So this is not equals to what we are getting. So our assumption is wrong here. This is not an alpha particle. Now let's assume that this is a proton or a positron, right? So for a positron, let's assume the charge, right? Or let's assume the mass. It's up to you. You can assume anything. You can assume the charge or mass, right? So let's assume the charge of a positron is 1.6 times 10 to the power of minus 19. So 1.6 times 10 to the power minus 19. You will find the mass from here, and the charge is 1.76 times 10 to the power 11. So your mass would be 1.6 times 10 to the power minus 19 1.6 times 1.6 times 10 to the power minus 19 divided by the mass to charge ratio, which is 1 to the power minus 31. So mass is equals to 9.09 times 10 to the power minus 31. So positron has the same mass as electron, but only it is an antimatter. It is, you can say, it is the antimatter of an electron, right? So only the charge is different. So electron and positron, they are the same thing, but they are matter and antimatter. So it should have the same mass as the for the mass of proton, electron. So we have the mass of electron provided here. If you just, yeah, so the electron has 9.11 times 10 to the power minus 31. And if you look at the mass that we got here, right, that mass is also around the same exponent, same order. So we can say of on these results that this would be a positron, right? We got 9.09, that is 9.1. So we could say this is positron. So this was the last question for this paper. I hope that it would have been a very helpful session for you. So looking forward to work with you guys, and yeah, inshallah, take care. Allah Hafiz.